Effects of concentration and rate of chemical reaction. Now in this experiment we will need 6 test tubes. We'll label these test tubes test tube A, test tube B, C, D, E and F. Now the first 3 test tubes A, B and C will contain sodium hydrogen carbonates, while test tube D, E and F will contain acetic acid, vinegar. We can start the experiment now. Test tube A will contain 3 spatulas of sodium hydrogen carbonate, which is also called sodium bicarbonate. Test tube B will contain 1 spatula of sodium hydrogen carbonate, while test tube C will contain half a spatula of sodium hydrogen carbonate. We can now put the sodium hydrogen carbonate into the various test tubes. Now, to start with is test tube A, which is to contain 3 spatulas of sodium hydrogen carbonate. Now you should take note of how it is being loaded. The level is a kind of water level. Now you don't excessively fill it. Don't excessively fill it. Now it's water level filling. Now that is 1 spatula. Yes. Now we need the second spatula and then the third spatula. Observe carefully. If you excessively load the spatula, then you have a tough time to make solution with it when you want to dissolve it, because it will kind of form a saturated solution where you will not be able to dissolve all the sodium hydrogen carbonate in the 10 ml water that will be added into it. So you have to load the spatula a kind of water level. Now we can put the sodium hydrogen carbonate in test tube B. Now test tube B is to just contain 1 spatula of sodium hydrogen carbonate, the same loading water level. Okay, now we are done with that. Now we can go into, we can load the third test tube, which should be test tube C. After measuring the sodium hydrogen carbonate into the test tubes, we'll now measure 10 ml of water into each of the test tube A, B and C to make solution of the sodium hydrogen carbonate. I want to dissolve the sodium hydrogen carbonate to make true solution. Now you must ensure that all sodium hydrogen carbonate in the test tube is completely dissolved before you can carry out the reaction. Now that is 10 ml of water into test tube A. Try as much as possible to dissolve all the sodium hydrogen carbonates. We just need a true solution to be formed. A true solution is a solution where the residue, the solute, is completely dissolved in the solvent, where you have a clear solution. Now 10 ml again for test tube B. Yes, you must ensure that every particle, the last particle of sodium carbonate sodium hydrogen carbonate is dissolved. Now that is test tube C with half a spatula of sodium hydrogen carbonate. 10 ml of water is added. Ensure that all sodium hydrogen carbonate is completely dissolved. Our test tube A, B and C are now ready. Now we can prepare for the acid solution, which is vinegar. Now we arrange test tubes and label them test tube D, E and F. Now test tube D will contain 5 ml of the acid, which is vinegar. Test tube E will contain 3 ml of the acid, which is vinegar. Then test tube F lastly will contain just 1 ml of the acid. Now we prepare to measure our acid into the various test tubes. Now 5 ml of the acid into test tube D. Okay, that is 5 ml. Now transfer it to test tube D. The next thing, you measure 3 ml to be transferred to test tube E. Next is to measure 1 ml of the vinegar, which is the acid, into test tube F. It can now be transferred into test tube F now. The 1 ml of the acid. The next thing to do is now to add water to make each of them to 10 ml. Now test tube D, which has 5 ml of the acid, we can now add 5 ml of water to make it 10 ml solution. The same thing for test tube E, which is 3 ml of the acid. We'll now add 7 ml of the water to make it 10 ml. Then test tube F, that has just 1 ml of the acid, will add 9 ml of water to make it 10 ml solution. After adding the water to the acid, you may need to agitate properly for proper mixing. After that is done, we are ready for our reaction. We can now pour solution A into solution D and observe the reaction. You must keenly look to observe the rate of bubbling, which is effervescence. We can now pour solution B into solution E and observe. While observing, don't forget to compare the rate of bubbling. Finally, we can turn solution C into solution F. Now these two are the least concentration. Observe. You can see the effervescence is very low. We can now make conclusion of the rate of the three reactions as we compare the three. Effect of temperature. Now, for effect of temperature, we have 4 test tubes. We label them test tube 1, test tube 2, test tube 3, test tube 4. Now, test tube 1 and test tube 2 will contain 3 ml of the acid, while test tube 3 and test tube 4 contains 3 ml of the base. Here we vary the temperature. We react a pair at room temperature while the other pair at higher temperature, which we will now take test tube 4 and test tube 2 to a hot water bath. Now we heat it to near boiling. Then we react the both of them. Remember, test tube 2 has the acid, test tube 4 has the base. When we heat them near boiling, we react the both of them and then we observe the effervescence, which is the rate of bubbling. Thereafter, we'll react the two pair, test tube 1 and 3 at room temperature. Now observe their reaction. Now we can take test tube 1 and test tube 3, which were not heated. Now they are at room temperature. We can react them and observe their effervescence. Now you can see the rate of bubbling. Compare with test tube 2 and 4 that were heated. You can make your judgment and conclude which of them has faster rate of reaction. From this reaction, we can now make the following conclusion. Under effect of concentration, at higher concentration, the rate of chemical reaction becomes faster. It then means that the rate of chemical reaction is concentration dependent. Also, under effect of temperature, at increased temperature, the rate of chemical reaction becomes faster. It also means that the rate of chemical reaction is temperature dependent.